Hey everybody, it's Mr. Oaks. So today we're going to talk about something that seems relatively simple, but I find that a lot of students do have a tendency to make mistakes with this, especially when they have to do whenever they have to do a describing. So we're going to talk about intervals of increase and decrease. Now again, this is relatively simple, especially when we're dealing with something like a linear function. When we have a linear function and we're asked to describe it, what we can do is we can talk about the relationship between the different values, such as the independent variable and the dependent variable. Now you'll notice on this graph there are no numbers whatsoever. And really, even the description in this case is just speed for our dependent or y-axis and time for our independent or x-axis. So basically what we're going to do is we're going to look and see, well, what's the relationship between these two things? So what we can say in this case is I notice that as time is increasing, the speed is decreasing. All right, so we could say as time increases, speed decreases. And so that's their relationship. As time increases, speed decreases. Well, what does this mean for the function? Well, as you notice, this line is angling downwards. So this function is decreasing over time. So we can say the function is decreasing. And that's really all we do. We was to figure out, well, what's going on here? The function is decreasing. So in the case of a linear function, it's going to be relatively straightforward if both the independent and the dependent variables are doing the same thing. They're both increasing or they're both decreasing. Then the function will probably be increasing. You'll notice it starts to angle upwards. If they're doing opposite things, we get what we see here, decreasing function. That's really all you're going to say. It gets a little bit more interesting when we have, come back to me, stop being fuzzy. I always wonder why it does this. It just gets fuzzy. We're going to notice that it's a little bit different when we have a nonlinear function. Trying to get it to clear up. Come on, come into focus. Come into focus. Come into focus. Come into focus. No? We're not going to do that? Okay. Because what we're going to have when we have a nonlinear function is we are going to have what are called intervals. They're going to be intervals that change over time, depending on the graph. So you can kind of see here what we have just got more fuzzy. Cool. What we have here, which you can barely see, is we have this graph where you see it's curved. Okay? And come on. Oh, you don't want to agree with me today, do you? There we go. Okay. All right. So what we have here is this nonlinear graph. You see it's curving. Okay, it's not a straight line. And I broke it up into 3 different intervals. So we have this first interval here in this section. We have this second interval in the middle, and then we have this third interval. And what we would do is we would describe what's going on in each interval, what is happening with the graph in each interval. So first we look in interval 1. So I say interval 1, and we look at the line, and we notice that it is, as time is going, so we have time and height. So we have time in seconds, height in meters. So I notice that as time increases, the height's decreasing. So in this interval, interval 1, the function decreases. Okay? So the function's going down, it's decreasing. In interval 2, we look and it's flat. It's completely flat, or at least I've tried to make it completely flat. At this point, there is no change in the height whatsoever. So at that point, the function, it's no longer decreasing and it's not increasing, so it's constant. All right? The function is constant. Make sure I don't write on the wall. Okay, so the function is constant here. It's flat. There's no change. It's not going up. It's not going down. It's staying constant. So we would say the function is constant in interval 2. In interval 3, I notice that now that line is angling back up. So it's now increasing again. Okay? So we would say here, in section 3, in interval 3, that the function is increasing. Oh, it's gonna get all fuzzy again. Oh, it's old fuzzy. Oh, you don't want to agree with me today, do you? So that's the magic trick. Now, all right. So that's how we do this. That's how you want to play, camera? That's how you want to play? Yeah, that's how we're going to play. All right. So, interval 1, function's decreasing. Interval 2, the function here is constant. Interval 3, the function is increasing. Maybe this is someone's on one of those skateboard ramps, and they're starting at the top, and they're coming down, and they hit the flat part, and they come back up. And that's what it looks like. That's what it could be. And that leads us into our last thing. Let's try to take this off and not make it... There we go, not fuzzy. The last thing we want to do is, now we have here, we have a graph, and I'm noticing, I don't have any specific intervals laid out, but I want to describe what I think might be going on here. So I notice I have time in seconds, and I have a height in feet. So really, if I'm supposed to describe what's going on here, I just have to think of a scenario that could be describing what's going on in this graph. So I don't want to do something that's not like, I don't want to talk about, oh, a car drives down the street and it stops at the stop sign and then it goes, that's not what's happening here. It's talking about a height, not a distance or anything. I shouldn't say, not a distance, not that. It's talking about a height. It's not talking about driving somewhere. It's not talking about like a flat area. We're talking about a change in the vertical distance, not in the horizontal distance. I also see it's taking seconds. It's happening quickly. So I don't want to say that, you know, how long that someone's walking up a mountain for a number of hours and then comes back down the other side and it takes hours, because it's only seconds. So it's going to be something easy. you know, I could say that someone was going up a ladder. Okay, someone's going up a ladder. They needed to change a light bulb, so they went up the ladder. They changed the light bulb. They came back down the ladder. That makes sense. All right. John climbed a ladder. All right, so he climbed a ladder, changed a light bulb. All right, which would mean he's staying at the same height for a little bit. And then climb back down. Okay? I have to use what the graph is telling me in order to write a scenario that actually makes sense. This is just one scenario. He went up the ladder, stayed there to change the light bulb, came back down the ladder. It could have been something like someone walked up the stairs, then was at the top of the stairs and was like, oh shoot, I meant to bring the laundry upstairs, and went back downstairs. Basically, that's all you got to do is figure out, well, what happened that this graph would make sense for. You can have graphs that they just keep, you know, they go up, then they flatten out, then they keep going up. Well, you got to look, what's going on? You know, and they might have a slight description of what is happening, you know, but you have to fill it out. Okay? This one is where a lot of students get lost because they don't know how, okay, it's very open-ended. It's, what am I going to write? I have to write a situation? This isn't when it says what's happening in the graph, they're not asking you to be like, well, the line went up, then it stayed flat, then it moved down. They want something like this. All right, John climbed the ladder, changed the light bulb, climbed back down the ladder. I hope this was helpful for you guys. Again, this isn't something that's very complicated. You can kind of look at a graph and see what's going on with the line. It's this last part, the description, coming up with a scenario that can usually trip students up. But if you just use your imagination and really pay attention to what the graph is kind of telling you and the different, what the axes are, the time, height, distance, whatever it's talking about, you can come up with a scenario that actually makes sense. I hope this video was helpful for you. Please like and subscribe. Comment if you feel that you would like to hear about me discuss something else. It'd be very helpful. I'm Mr. Oaks. Again, I hope this is helpful. Please, education, it's the thing that's going to make you the best person you can be. So don't be afraid to learn, and I'll see you next time. If I didn't flip my mouse upside down. Almost had a nice ending. Oh well. I'll see you next time.